Hello, hello. Today we're going to talk about our first Linux vulnerability. So let's talk about etc password. Etc password is a file very important to a Linux system because it contains all of the config info about users. So any user on the system, their info, their details, how the system knows to use that user is located in etc password. So let's go ahead and do an ls on it to see what its permissions are, and we'll see it's 644. Root can write to it, and anyone can read this file. So we don't want to store anything sensitive here, okay? And if we were to look at this file, you'll notice it has a very confusing syntax. It's a lot to take in, but I'll break it down. Each line here corresponds to a specific user. You'll see that the very first word on each line is the name of that user. And then you have a bunch of fields separated by colons. So here I have it broken down where each field, I explain what it is. The ones where the names are up here means you can usually ignore them. It's not too relevant in terms of being able to be manipulated. But the ones down here definitely could be backdoored, so you should investigate those. So just going from left to right, the fields are first the name of that user, then we have the password for that user. Remember, etc password is publicly readable, so we don't want the password to be stored in here. It's a bit of a misnomer because of historical reasons. But eventually people realized, hey, storing the password or even the password hash in a place that's viewable by everyone is a really bad idea, because then anyone on the system could see anyone's passwords. So instead, all of the passwords got exported to this other file called etc-shadow, which we'll explain another day. And instead, etc password has this X here, which basically just signifies to the system, hey, this user has a password, it's in etc-shadow, so go look there. So that is the password field here. Then we have the user ID. This is a number corresponding to that specific user. System users have user IDs, as you can see here, anything from 1 to 100 and so on, while users created by us, the end users, typically will have IDs 1,000 or higher. Okay, so these are user accounts and these are service accounts. And you'll notice that root always has a UID of 0. This is how the system tells, hey, this user should have special permissions if they have UID 0. Okay? Then we have the GID, which is the group ID. Basically, each user corresponds to a group, and we can group users together into a group. Not too relevant for this talk. We'll mention it more when we talk about etc group, but that's that. Then there's a description of what the user, who the user is, what they do. Here's the home directory of the user. So when you log in to a user, where are you redirected to? In this case, every time I pull up a terminal, let me exit and let me pull up a new terminal. So this is basically me logging into my user Pukey, and if I do a pwd, it's home Pukey. And if I look at my etc password for Pukey, you'll see that my home directory is home Pukey. So whenever I log in, this is where I get redirected to. So that's that. And then lastly, we have the login shell. So right now, when I logged in, it took me into a bash shell because in etc password, my login shell is bin bash. You could have all sorts of things, bin sh, bin fish, bin zsh, whatever the user wants. But you'll see that most of these users tend to have something specific. In this case, user sbin no login. What this is it's basically a dummy shell that just says, hey, this user isn't supposed to have a shell. They're not supposed to have interactive logins, so do nothing. If you try to log in as any of these users, even if they have a password, you'll just not be able to have a shell, which is good for security reasons because these users are only meant to run system processes. They're not meant to be able to log in and do interactive things. So that's what user sbin no login is for. And also another one you'll see is bin false. Both of them do the same thing. Pretty much they just say, hey, you can't log in. So those are all of the fields for Etsy password. Hopefully that makes sense. If you want to learn a bit more, this blog explains it in more detail, but let's move on. So now let's talk about the exploits. So down here are the fields that we could exploit, starting with username. As Red Team, we could make backdoor users. The idea is that there are a lot of users that exist on a system. As you can see, this is just a default fresh image for Ubuntu, and it already has so many users because a bunch of systems and services need users to do their thing. You'll notice that also some of these users are really weird. For example, we have the nobody user. This is a legitimate user. It's meant to be basically a user with the least privileges possible. The idea is if a service ever needs to execute something as if they were nobody, then they could use the nobody user. This idea of let's keep least privileges. And there's some other ones that are kind of weird. We don't have it here, but there's also corn oops, which is a silly name that's basically anytime the kernel errors or crashes, corn oops handles that. And there's just a bunch of weird ones. Sometimes you have mosquito, which is for a specific niche service. You have rtkit, which does not stand for rootkit. It's something else, a standard service on the machine. We have a lot of these different things. It's pointless to go into each one in detail. But the idea is it is confusing, and it's going to be easy as Red Team to blend into this noise, to be an imposter on the system. So there's two kind of techniques that are pretty common and useful. One is typo squatting. Basically, let's make our name similar to a legit user so it looks real, but actually one of the characters is different. An example could be instead of the UUCP user, so we have this user UUCP, what if instead we made the user UCP or UUUCP? Either of those look really similar, so at first glance no one would suspect it, but it's not legitimate. So that's the idea of typo squatting. And again, most of these users correspond to systems or services, some of which are essential for the system. So what if we just either one, made one of these users able to log into and do things with, or two, include a user for a fake service. The idea being that for each service, we have a user specifically for it. For example, Apache, when you install it, there should be an Apache user on the system. So it's easy to basically make fake users for fake services so that Blue Team doesn't suspect it because it looks legitimate. And so those are kind of the tactics of Red Team. So let's say we wanted to actually add a user. We could edit Etsy password manually. However, that's usually a bad idea because if you mess it up, that's really bad for the system, and it is easy to mess things up. Unless you're scripting and you know your script works, probably don't want to edit manually. Instead, we have these utilities like user add. So in order to use it, I need to be root on the system. So let me go ahead and escalate. And so let's do this. There's two commands I can use to add users. The first is add user. So let me do add user Bob. This one is newer and it does all the things. You can see it sets a UID, it creates a group, it creates a home directory. It's doing all of those things that I talked about with you. And it actually prompts you for a password to set. So let me just do Bob as the password and ask for details. So let's say first name, last name, and 1, 2, 3, 4. Yes, it's correct. And now if I look at Etsy password and I look for Bob, we'll see Bob is here. All the details have been filled out, including the description. And so that's everything about the user. This is add user, which is a newer utility. It's easy to use. However, there is also the user add. Confusing, but different. So user add, so let's do user add Bobby. And you'll notice it doesn't prompt me for anything. It just does it. So what's going on here? Well, if I look at Etsy password and, oops, typo. If I look at Etsy password and I look at Bobby, you'll see that it creates the user, okay, and it creates a group ID for it. But there's no description, and default shell is bin sh. Okay, it does that. Another thing we'll notice is if we look at Etsy shadow, which I'll talk about in another video, I just want to point out that these two things are different. Bob, you see, has a password hash here because we set the password. Meanwhile, Bobby is just an exclamation mark. It doesn't have a password, and so you couldn't actually log in as Bobby because you never set the password. So user add is the OG utility. It always works on whatever system you want, and it doesn't do much. It just creates the user and adds it to the necessary files. Meanwhile, add user does all the things that I just showed you. So this is how Red Team can create users. But let's shift gears and think about the defensive. How can Blue Team detect these malicious users? And that's where a tool that I developed comes into play. So let's go ahead and documents, BlueDaBaDee, Linux, yes. Go into this users directory and it includes this tool I made. So let's go ahead and run a sudo list users color. Wow, you see this pretty output. So this is a tool that I developed to help us understand what's going on in Etsy password and quickly enumerate through users to detect any malicious modifications or configurations going on. And here's the description. The idea is it goes user by user and it lists them along with a bunch of different checks. For example, is this a root user? Do they have UID 0? Is it part of the sudo group? Can you do sudo? Can they log in? Do they have an active connection? Do they have a home directory? All of these different things are fields that I check for. And over here, you'll see that the users are color-coded. So in here, we have a few files. For example, Adam users. So this is the administrative users. Let's hold on. Let's go ahead and let's do BlueDaBaDee to actually plant a vulnerability. I want to do the typo user vulnerability for this demo. Okay, so it worked. And so if I were to cat my current set, you'll see typo user has been selected. So let's go ahead and set that up. Okay, and so we're told that this is the admin user and these are regular users. So this is important because in CCDC or any competition environment, you'll be given users that you need to have. And so it's important when enumerating that you don't accidentally identify them as malicious and start deleting them, okay? So I'm gonna go ahead and go back into users and you'll see that we have 4 text files here. I'll just go through them one by one. Adam users are the administrative users on your machine. In this case, it should be Jotaro. So we have root, because there's always root. And let me just add Jotaro, and we're good. Next is regular users. In this case, Jolene and Joseph. So let me add Jolene, Joseph, and let me also add my current user, just because I know that should be a user on this system. And let's go ahead and look at these other files. So I also have an essential users. These are all of the users that have to be on your system. These are essential for the operating system to work as expected. And if you mess with any of these users, your system could crash. I don't know, it's really risky and you shouldn't do it. So these users should not be touched. And as you can see, some of them have funny names, like I was saying, like Nobody and Corn Oops and Whoopsie, but these are all legitimate users. Meanwhile, we have the service users. These are users that are maybe needed. It depends on what services you're running. For example, Apache is only needed if you're running an Apache web server. If not, then maybe you want to discard that user, you know? An example of some users that are going to be there but you really don't need, the games user is a legacy user that existed on these operating systems for keeping track of game scores. It's a very old thing that we don't need anymore. So you could honestly just get rid of that user and nothing would change. So those are the 4 files that determine basically what users do we expect to see. And when we run list users color, it uses those files. Oh, remember to run it as root. And oh, here's a cool trick. If you do bane, these 2 exclamation marks, it repeats the last command. So in this case, it just did sudo of the previous command. And you'll see here, it lists all these users. So blue are admin, which is why you see Jedro is blue because he's an expected admin. He should be part of the sudo group, so that looks legit. We see regular users, like Jolene and Joseph, are green. They're expected to be users, not admin users, just regular, which is what we see here. They are regular users that can log in, but they are not admin. Meanwhile, we have these white users, which are the system users that you should not touch, and then yellow users, which are the service users that are like, it's your judgment. Do you want to keep them or not? And lastly, we have things that we have not seen before, these red users, which are most likely malicious, but maybe it's a service user that we just didn't know about because we've never encountered this service before. So this is explaining how we enumerate the users. Hopefully this makes sense. It's definitely easier than manually going through etc password and looking up each user. The idea is here, when we run this, we can just very quickly see, ooh, red is bad. We do not want Bob. We do not want Bobby. And we definitely don't want Corn Poops. Corn Poops looks like it's a typo squatted user trying to impersonate Corn Oops. But nope, that is not legit. We do not want it to be there, especially not being able to log in. So that is identifying the users. We use this tool to do that. Once we identify the malicious users, we can disable them. So there's many different ways you can disable a user of varying different degrees of effectiveness. For example, the most extreme way would just be to delete the user outright using this command userdel. Tac rf to force and recursively delete it. Oh yeah, to also delete the files belonging to it. So in this case, when I run this command, it deletes the user, and it also removes their home directory and their var spool directory. But this is pretty extreme, especially like what if we made a mistake and that user was actually necessary? So there are more tame and recoverable ways of disabling users. Specifically, there are 3 different things you can do. 1, you can lock the account using usermod tac-l username. And so what this does is it locks the account, which basically means you can no longer use a password to authenticate. And so what that would look like is, for example, let's do this. Let's do Bob. Okay. So if I wanted to grep for Bob in etc shadow, and let me sudo, you'll see he has a password hash here. If I then usermod, actually, let me just become root. So I don't, okay, there. So if I usermod lock Bob, okay, so he should be locked now. And when I then grep for Bob in Etsy Shadow, you will see there's this exclamation mark at the start of his hash now. And so what this means is if I try to authenticate as Bob, it's not going to work. So for example, let me try to switch user to Bob. And if I enter his password, it doesn't work. It's an authentication failure because his password is locked. People aren't supposed to be able to log in. And so that works. We've disabled the user so no one can authenticate as them anymore. However, it's not foolproof because there are other ways to authenticate as a user that do not require a password. For example, SSH keys is one of them, which I'll make another video discussing. So there's another thing we can do, which is expire the account. So each account has an expiration date defined in Etsy password. It is this last field over here, which most of the time is blank because most of the time accounts don't expire. But let's say we wanted to expire an account. So again, I'm going to use a mod, tac E1, which sets the expiration date to 1, or in other words, as soon as possible. And let's do the user Bob. And so after I do that, I can again grep for the user, and you'll see he now has a 1 here. And so now, even if he was able to log in, so for example, let me go ahead and remove this here. So hash works, he should be able to log in, but let's try logging in as Bob. Oh, it tells me that it's expired. So authentication failed, I can't log in. And this is more foolproof because it works for anything, any mode of authentication. So that's step 2. And then another thing we can do is changing their login shell. So again, in Etsy password, we talked about how this last field is the login shell. When they log in, it's what they use to spawn the shell that they can do interactive things in. And I mentioned that for most of these users, you'll have something like bin false or user sbin no login. So the thing here is that for this, we could change it from bin bash to bin false. And that would also prevent them from being able to log in. So how can we do that? User mod tac s, this should be an s, not an l, for the shell. So if we do user mod tac s, mod tac s, let's make it bin false for Bob. And again, let me grep for Bob in Etsy password, and you'll see his shell is now bin false. Awesome. So now we've made it super secure. Bob should not be able to log in and do any damage to our system. So this is a nice and simple way, but recoverable way to disable a user account. And let's go ahead and look back at BlueDaBaDee because we did test the typo user vulnerability. And so what user was it that was added? Well, if I go back to my enumeration of users, so I would run the list users color, right? List users color. And I see all these users, and I see at the end, oh wow, corn poops. I bet that's the user that was added. I want to disable that. So let's go through the steps here. Let's do user mod tac l corn poops. Let's do user mod tac e1 to expire the user. And then let's do user mod tac s bin false to set their login shell to false. And with that done, let's go ahead and check our progress. And we did not work. Why is that? Huh. Oh. Oopsies. Sorry, it's just a typo here. It'll be fixed by the time this video gets out. Okay. Nope. Let me get rid of this. Okay. Let's go ahead and run the checker. And boom, we'll see it fixed. So what that check was doing is it just checked for Etsy password. Do we have the conpoops user? And was their login shell valid? And so you'll see here, it gives us a description of what just happened. Okay, so that is disabling users. And going back to Etsy password, that is the first field that could be modified. Now let's look at the second field, password. I mentioned that password should always be an X. So what happens if it's not an X? And the truth is, it's really interesting what happens. So if you remove this X from Etsy password, like we have here, what the system does is when you try to log in, it looks over here and it sees, oh, the user doesn't have a password because it's blank. Well, I guess you don't need to authenticate. You can just become that user. And so you'll see that when you do this, you can just SU straight into that user, nothing needed. So let's go ahead and look at Etsy password. And let me remove that. Okay. Also, let me make sure that he's not expired or anything. So Bobby is not expired. Okay, cool. And so now, let me just SU to Bobby. And boom, I am Bobby. Clear? Okay. I'm Bobby. I didn't have to provide a password or anything. I'm just let in because the system says, hey, Bobby, you don't have a password. You're cool. You can authenticate. So that is honestly really powerful. And there's even more to this vulnerability, which is that even when you reset the user passwords, there's still going to be a problem. And so what happens is that when you use a utility like passwd to reset the password, what the system will do is it looks in Etsy password and it doesn't see an X. It sees a blank. So it thinks, oh, the password is supposed to go here. So let me just go ahead and put the password there. So it puts the hash for your password right there in Etsy password, which is a huge problem because remember, Etsy password is world readable. Anyone can read this hash, which means that anyone can crack their password and log in as them. So this is, in my opinion, a really cool vulnerability because one, can authenticate without a password, and then two, you can, if they try to patch it, you can just read their hash. So then the question becomes, how do you actually disable this? Well, it's really easy. You just put that X back in there manually, okay? You can reset the password afterwards, but first just make sure you have an X in there so things work as normal. So let's actually go ahead and test this. So I want to, again, let's go back to BlueDaBaDee, okay? And let's run, let's pick, and for this, I'm going to do the no password module, okay? And so if we look at our current set, boom, no password. So let's go ahead and set up. And okay, seems like it worked. If I run my checker, yep, okay, I haven't patched it yet. That's great. So what happened? That's a good question. Let me go ahead and start off by going into users and again, running that list users color. And let's see if it detects anything. And we'll see here, oh, there's an extra X for Jotaro here, and also for Bobby. And what does this X mean? Well, this X corresponds to the N, which means, oh, no password in Etsy password. That's what we just talked about. So if we were to look at Etsy password, and I go to Jotaro, you'll see, uh-oh, his fin is blank. He has no X, which means that we could log in without a password. So let's go ahead and fix that by just putting the X there, and we're done. So now if I were to run my checker again, yay, we passed it. Congrats, you have just fixed your second vulnerability. So let's talk more about etc password. So etc password is complicated. We mentioned that we could backdoor the user. We could backdoor the password. So what's next? Let's backdoor the user ID, okay? And so I mentioned that the system treats UID 0 as root. Now, there's no specific requirement that only root has to have UID 0. I could make anyone's UID 0 if I could modify etc password. It's pretty simple. I just go to my user and change their thin to 0. So for example, let's mess with Bobby again. 0. Now he's root. He can do root stuff. And so if I wanted to switch user to Bobby, I am Bobby with UID 0. I am root. So I can do things like edit etc shadow because I am root, which is, really bad. So we don't want that. And so how do we fix it? Well, you would just change it back. So how do we fix this? Change the UID to anything except 0. If you don't know what to make it, a good rule of thumb is to just make it their group ID, because you'll see most of the time when we make a new user, the user ID and the group ID are the same thing. So here I see his group ID is 1002. So let's go ahead and make this 1002. And that is that. So now let's go ahead and do BlueDaBaDee. I want to pick a certain vulnerability, and let's make it this one, the UID root one. Let's do that. So pick module UID root. And again, if we look at our current set, we see that we selected it. So let's go ahead and let's set up this vulnerability. Okay, cool. And if I run the checker, you will see, we have a vulnerability. Let's figure out what that is. So again, that's step-by-step process. First thing I'm going to do, I'm going to look at my users. I'm going to run list users color.sh. And it's going to go through and it's going to list everything. And we see, does anything look unusual? Oh, I see this X here for Joseph. What does that X mean? Let's go ahead and figure out. So this X means all, which means UID 0. Oh no, that's what we just discussed. So let's go ahead and let's look at etc password. And we'll see for Joseph, he has UID 0. That is not good. So let's go ahead and fix that by making his UID the same thing as his group ID. So I'm going to change that to 1003. And, oh, that's not good. So in this case, we see multiple users have group ID 1003. And so we see 1002, 3, 4, something, then 6. So I'm going to guess this is probably 1005. If we check, no one else has 1005. So this should be fine, causes no issues. So let's go ahead and do that. And let's run our checker. And okay. That should not be happening. Let's go ahead and look at root. What is it? UID root? Yeah. And what is it checking? It's looking for Joseph. And it's looking for 0. Okay. Wait, what happens if I do awk? Okay, so this is just printing the first and third fields from etc password. And if I grep for Joseph, oh, that's why. Okay, sorry. Let me fix this. Okay. Okay, now let's run the checker. Yes, okay, it worked. And just to test, let me pre-plant again. Oh shoot, let me set up again. Okay, and let me check. Vulnerability exists. Uh-oh, so let's look at etc password. And this is 0, so let's set that again to 1005. Ooh, okay. And check again. Congrats, you've patched it. Awesome job. That is your third vulnerability you have just managed to patch. But there's more to etc password. Again, this is a really important file, so we have a lot of things that we could backdoor. So we covered username, we covered password, we just covered UID. So last thing to cover is the login shell. So the login shell could be backdoored. There is some sneaky things we can do. I mentioned that what you want is you want user sbin no login or bin false. For this last one here, if you want the user to be able to not log in. Okay? So going in with that assumption that this should be user sbin no login or bin false, how could red team try and backdoor this? Well, there's two ways. The first is, once again, we could typo squat. So user sbin no login. That's kind of long. People aren't going to remember it exactly. So you could do something like changing it to user bin no login. So if I did user bin no login for this user, this is not the same thing as this. You see, this is sbin, but this is bin. But the two sound very similar, so it's easy to get confused and think that this is fine. And so what you could do is you could then create a file on the system, user bin no login, that is just a copy of bash. And so that's what we would do here, right? So in this case, we cp sh to user bin no login. And so this is a backdoor of this, okay? It's just impersonating that. So that's one thing we could do. Another thing we could do is we could just replace that binary directly. So even though this one says it should not allow logins, if we actually ran this, we would see, oh, it's a bash shell. That's not good. So doing either of these two things would allow us to log in as a user that otherwise, if we were auditing this system, we would think, oh, they're not allowed to log in. It says no login. So this is a sneaky thing you can do. How do you defend against it? Well, you want to make sure that it is actually no login and that it is actually not allowing them to log in. So the first thing is, if it's a user that you know isn't supposed to log in, make sure it says bin false or it says user sbin no login, and that it says exactly that, not something similar, okay? You'll notice that sync always has bin sync. That is normal. So even if we look here, sync is bin sync. That is normal. Do not mess with it. It will break things. Other than sync, all of these should be saying user bin no login or bin false, except root, because, you know, we want to log in as root, and our users down here because, you know, we want to be able to log in as these authorized users down here. But the other ones, they should be changed to user sbin no login. So that is one thing we can do. But like I mentioned, red team could do something like cp bin sh into bin false. And so if you do that, that is pretty bad, because even if when someone logs in and it says the login shell is bin false, it's going to do it. It's going to say, oh, this is a shell. I can now do shell stuff. Okay? So this is bad. So like, who am I? You see, it's a shell. I can do stuff here. So how do you detect this? Well, you could do diff bin sh bin false, and you'll see it doesn't return anything. If we did diff bin sh user sbin no login, you'll see, oh, it says they differ. So this is good because it tells us that, hey, these files are actually different. Here you can see, oh, this file has been backdoored because it's the same thing as a login shell. That's not good. So we want to be able to fix this. How do we fix it? By replacing this binary with actually, the legitimate bin false. There's no way to do that conveniently on a system. What you would have to do is look up online the the source image for this operating system and download the file that way. So you just get a clean copy from the internet of bin false or user has been no login. And that's one thing you could do there. So that is how you deal with that vulnerability. And you'll notice that inside BlueDaBaDee, I believe we do not have anything specifically testing this. Instead, it's combined with other ones. So like when we did the typo user, it also did something else. So let me go ahead and pick TAC-M typo user. Okay, and let's go ahead and check. So you'll see that the description says that, yeah, we had the impersonating user, but it also did the login shell typo squad. User has been no login with user been no login impersonating user has been no login. So some of these vulnerabilities I have inside BlueDaBaDee needs to make use of that fake login shell so that you can actually log in as that fake user. But that is that. And with that, oh, there's one more thing. There's even more to Etsy password. So we talked about this, and this. That's already 4 different vulnerabilities you could have. But there's one last thing, and that is the permissions of Etsy password. So right here, the permissions are 644, right? Root can read and write. Everyone else can just read. So what if, as red team, we change this to something else? For example, 666. So that's what we'll see here. You change it to 666. Now anyone can edit. Anyone on the system can make Etsy password whatever they want, and thus they can add all of those backdoors that we discussed previously. So as blue team, how do you fix this? Again, pretty simple, just change it back to 644. It's really a simple vulnerability. So let's go ahead and let's do, let's pick module, and I want it to be, let's see, which one tests this? That is going to be perm password. So perm password. Okay. And if we set up, okay, let's check. Uh-oh, it's bad. And so if I ls Etsy password, you see, oops, it says 666. Let's fix that. So chmod 644, Etsy password. Okay. And let's run our checker again. Boom, it's great. And if you aren't familiar with what the 644 and the 666 means, if you don't understand how permissions in Linux works, don't worry, we'll have a video coming up in the future describing how that works. So with that, we have completely covered Etsy password. It's so in-depth, I don't think there's really anything we missed. Congrats on making it through this. You are now much smarter than you were before, and you've already made a huge progress into securing your system, because now you know how to secure any user. So with that, thank you for watching, and I'll see you in the next one. Bye-bye.